All right, so chapter 3 is all about using the derivative, Now that we learned pretty much all the derivative rules, how can we apply it? One of the big applications of the derivative is using it to reveal information about a function's graph, without even knowing what the graph looks like. The first derivative of a function will tell us one thing. The second derivative of a function will tell us another thing, okay? So the first few sections are kind of in that vein of working towards a lot of theory, a lot of definitions that help us describe the graph of functions. And then the last two sections are more like practical applications in terms of like physics examples, which we call related rates, and then optimization type problems, max and min stuff. So we'll start with max and mins and we'll kind of end with max and min. So here before lunch, let's just quickly define extrema, because it's maybe a term you haven't heard before. Extrema is a math term. It's plural for maximum and minimum. Okay, it's a plural term, plural. And when we say max and min, of course, that also means maximum y value and minimum y value. So again, typically when we talk about max mins, we're talking about y values that can represent all kinds of things like maximum temperatures, maximum efforts, whatever, and they occur at x values at certain times. Typically, is what we measure. And there are two different types then of extrema. We have the local, which is known as the relative as well, and then we have the global, which is known as the absolute. All right, so we need to know the difference between the two. So we'll just kind of start real quickly with this definition of what is known as either an absolute max or min, or a global max or min, or notice how it's in parentheses. What that means is it's not even needed. You don't even have to, have an adjective in front. It's nice because, the goal is to communicate and you don't want to be misunderstood. But if I just say max and min, it means absolute max or min. If I just say max or min, it means global max or min. All right. So what does it mean to be a maximum y value on an interval? Well, that's the first one. It says that we have a y value that's a maximum on an interval I. And we'll talk about different intervals throughout this section. It can be either open, closed, or half open, half closed. The y value is f of c. That y value, f of c, is the maximum on the interval if and only if, that's the IFF, that y value, f of c, is greater than or equal to all the other y values, f of x, on the interval. So notice we don't say if it's the biggest y value, if it's the tallest y value. We say greater than, which means biggest or tallest, but we also say equal to, which kind of leaves the door open for one special type of circumstance. But for the most part, it's going to be easy to tell if it's the biggest y value because it has the largest magnitude, or it has, the largest value on the interval. And similarly, we have an absolute minimum or a global minimum or just a minimum. They all mean the same thing on an interval. If that y value, f of c, is less than or equal to all the other y values on the interval. So once again, we leave the door open, not just saying it's the smallest y value. It's less than or equal to all the other y values on the interval, okay? We'll try it with a graph when you get back from lunch, but at least we got some definition in before lunch. Come back from lunch quickly, fastly, exponentially.